Now let's solve the word problems of HCF. We have here D example from exercise 4.5. Manisha made 20 laddus, Ritika made 30 laddus and Divya made 50 laddus. They packed them in boxes such that each box has equal number of laddus and no laddus remain unpacked. Find the maximum number of laddus that can be packed in each box. Also find the minimum number of boxes required to pack these laddus. To find the maximum number of laddus that can be packed, we have to find the HCF. So before finding HCF, let's write the given things. So what are given things? Number of laddus. Okay, so made by these people. Let's write. So these are the given things. Okay, Manisha had made 20 laddus, Ritika made 30 laddus, Divya made 50 laddus. Now, the maximum number of laddus can be packed in each box that we have to find. Let's write the statement. Yes. So what is a key? Our key is finding HCF. So let's find the HCF of 20, 30 and 50. Let's find the HCF by prime factorization, as 20, 30 and 50 ends with 0, therefore are divisible by 2. So let's start dividing by 2. 2 1s are 2, 2 0s are 0, 2 1s are 2, 2 5s are 10, 2 2s are 4, 2 5s are 10. Further, 10, 15 and 25 are not divisible by 2, therefore we shall divide them by 5. Why only by 5? Why not by 3? Because 5 plus 2 is 7, 5 plus 1 is 6 and 1 plus 0 is 1. And you know the sum of the digits should be divisible by 3. Thus 10 is not divisible by 3 and 25 is not divisible by 3. Okay, therefore we are going to divide these numbers by 5. So 5 2s are 10, 5 3s are 15, 5 5s are 25. Now further we have got here the prime numbers and which are not divisible further. Thus the highest common factors we have got here are 2 and 5. Therefore what is HCF? Therefore HCF is 5 into 2, that equals to 10. Therefore they can pack 10 laddus in each box. Therefore they can pack at the max 10 laddus in each box. So this is not our solution. Again, one more problem we have. What is that? Also find the minimum number of boxes required to pack these laddus. Now we got to know that how many laddus can fit into the box, but how many boxes do we need? That we have to find. So to do that, we have a formula. To find number of boxes needed equals to total number of laddus divided by number of laddus fits in each box. So now we have got all the details about total number of laddus plus number of laddus fits in each box. Okay, so let's count how many laddus are there. So let's find first total number of laddus. That equals to 20 plus 30 plus 50 and that makes 100. Thus there are 100 laddus. So let's find number of boxes needed by substituting the values, and number of laddus in each box are here. Therefore number of boxes needed equals to total number of laddus are 100 divided by number of laddus fits in each box divided by 10. So when we divide 100 by 10, we'll get answer 10. So how many boxes do we need? So we need 10 boxes to fit 100 laddus. Okay, so let's write the final statement. Therefore 10 boxes are required to pack 100 laddus. So let's see the next question now. Next question. Sarika, Meena and Sudha bought 16, 31 and 46 candies from a shop. They distributed an equal number of candies to children in the children's home such that each of them is left with one candy after distribution. Find the largest number of candies they gave to each child. Yes, so what we have to find here also, we have to find HCF, means at the max how many candies they have given to the children and they are left with one. Okay, so because of that we have to subtract 1 from each number. Okay, from 16, from 31 and from 46, because they are left with 1 and remaining number of candies they have distributed among the children. So let's write the given things first. Number of candies purchased by following people are as below. That is, Sarika has purchased 16, Meena has purchased 31, Sudha has purchased 46. And after distributing, they are left with one candy. Okay, so to do that, okay, we have to subtract 1 from each number. After distribution of candies, they are left with one candy each. Therefore, to do that, we have to subtract one candy from each one's purchase. Okay, so and then we have to find HCF. So let's distribute first. Let's first subtract one candy from each one of purchase. If they have left with one candy each, then they might have distributed this number of candies among the children, that is 15, 30 and 45. So let's see now how many candies does each one of them gets. Now let's find the HCF by prime factorization. As the ones place doesn't ends in even number, so these are not divisible by 2. Let's check whether these are divisible by 3. 5 plus 1 is 6, 3 plus 0 is 3, 5 plus 4 is 9. Yes, it is divisible by 3. 3 5s are 50, 3 1s are 3, 3 0s are 0, 3 1s are 3, left 1, 3 5s are 15. Further, these numbers are not divisible by 2, 3, and these are divisible by 5 altogether. Thus, 5 1s are 5, 5 2s are 10, 5 3s are 15. Now, 1, 2, 3 are not further divisible by any other number. Okay, therefore, we have to stop finding the factors, and therefore, here prime factors we have obtained are 3 and 5. Therefore, HCF of 15, 30 and 45 is 3 into 5, that equals to 15. So, what number of candies they have distributed among the children? Therefore, they have distributed 15 candies amongst the children. So, hence the solution. Hope you have understood this. Now, let's see the next part of this chapter. Lowest common multiple, that is LCM. LCM of two or more numbers is the smallest multiple among all their multiples that can be divided by those numbers without leaving any remainder. So, these concepts you have learnt in previous class. That is, during even revision also I had taught you how to find LCM. Now let's see the properties of LCM. The LCM of two or more numbers is their smallest common multiple. The LCM of two or more numbers cannot be less than the numbers themselves. If one number is a factor of other, the greatest number is the LCM. The LCM of coprime number is their product. Okay, so these are the properties of LCM which will help us to solve the problems. So let's see the methods of finding LCM. LCM by prime factorization method and LCM by short division method. So by prime factorization method already it has been solved, and refer the YouTube video 1. So where you will find the how to find LCM by prime factorization. So I'm not going to repeat the same. Now let's see finding LCM by short division method. So we have here exercise. Now let's solve the exercise 4.6. Find the LCM using short division method. Here we are using one vertical line, and then we are writing the numbers by putting the comma. Let's find the LCM now. So first I will divide by 2. Always we have to start with prime number, as 14 is divisible, so I will start with 2. As 21 is not completely divisible, I'll write 21 as it is. 2 7s are 14, put the comma, and 35 is not divisible by 2, therefore write 35 as it is. Further, let's see the number which divides 21 and 7 together. So we have a number 7, 7 3s are 21, 7 1s are 7, and 7 5s are 35. Further, let's divide this. 3 1s are 3, 1 as it is, 5 as it is. 5 1s are 5, 1 as it is, 1 as it is. Therefore, we have got here a set of prime factors. Therefore, after multiplying these factors, we will get LCM. Therefore, LCM equals to 2 into 7 into 3 into 5. So, let's find the product now. This will get the product 210, therefore LCM is 210. Similarly, you can solve for the example 72 and 32. Now let's see the last part of the chapter, that is word problems. So from exercise 4.7, we have a word problem. 3 bells of a temple began ringing at 9 a.m. The first bell rings after every 30 minutes, and the second one rings after every 45 minutes, and the third one rings after every hour. at what time will 3 bells ring together again? Yeah, so we have to find the time when all these bells ring together. Okay, so here they have given the intervals when the bell rings. Okay, so to find that at what time the bell rings, okay, all the bells rings together, to do that we have to find LCM. Okay, so to do that, first let's write the given things. What all things are given? The time is given and the intervals are given. Thus, time at which bell rings is 9 am. Duration of intervals are as below. Like first bell rings after 30 minutes, second bell rings after 45 minutes, and third bell rings after an hour. An hour means 60 minutes. So we have to write as a 60 minutes. What we have to find? We have to find the time at which 3 bells rings together again. So to find at what time these all 3 bells rings together, we have to find LCM. So what is a key? A key is LCM. So let's find LCM of 30, 45 and 60. So let's find the LCM. As 30, 45 and 60 are divisible by 5, I'll start dividing by 5. 5 6 are 30, 5 9s are 45, 5 12s are 60. Further, 6, 9 and 12 are divisible by 3. Therefore, 3 2s are 6, 3 3s are 9, 3 4s are 12. Further, let's divide them by 2. 2 1s are 2, 3 as it is, 2 2s are 4. Let's divide 2 first. 2 1s are 2, 3 as it is, 1 as it is. Further, 3 1s are 3, 1 as it is, 1 as it is. So now let's find the product of these factors that will give us the minute at which all 3 bells rings together. Thus, the product of all these factors is 180. And what is the measure of this? The measure of this is minutes. 30 minutes, 45 minutes, 60 minutes, isn't it? Therefore, 180 is what? Minutes. So, after 180 minutes, the bell will, all 3 bells will ring together again. Therefore, 180 minutes means 180 minutes is equals to, you know that 60 minutes is equal to 1 hour. Accordingly, 180 minutes equals to 3 hours. Therefore, after 3 hours, in the sense, after 9 am, you have to add plus 3. So, we'll get 12. So, 12 pm, isn't it? So, just see, therefore, so when we add in 9 am, 3 hours, it will be 12 pm. Therefore, at 12 pm, all bell rings together. Now, let's see the next problem. E. A certain number of vegetables can be arranged in group of 3, 4, 6 or 8 with no vegetables left ungrouped. Find the least number of vegetables for the arrangement. So here what they have given, they have asked that the vegetables will be grouped into such a number of groups. Okay, like a 3, 4, 6, 8. In such groups, they have to arrange the vegetables. So to arrange the vegetables in such groups, we should know the least number of vegetables we should have, isn't it? So to find the least number of vegetables, we have to find LCM. Yes, so let's write the given things first. So what all things are given? Number of vegetables arranged in group. So number of groups are here 3, 4, 6 or 8. And what is to be find out? Least number of vegetable equals to question mark. So to find the least number of vegetables, what we have to find? We have to find LCM. So what is key? Key is LCM. So let's find the LCM. 4, 6, 8 are divisible by 2. So let's divide by 2 by keeping 3 as it is, because 3 is not divisible by 2. So 2 2s are 4, 2 3s are 6, 2 4s are 8. Further, let's divide by again 2. As 3 is not divisible by 2, so 3 right as it is. 2 1s are 2, 2 2s are 4. Further, you can divide by 3. 3 1s are 3, 1 as it is. 3 1s are 3, 2 as it is. 2 1s are 2. Thus, what we have obtained here, we have got the prime factors. Okay, we have to multiply this together to get the LCM. Therefore, LCM equals to 2 into 2 into 3 into 2, that equals to 2 2s are 4, 4 3s are 12, 12 2s are 24. Therefore, there should be at least 24 vegetables for the arrangement in a group of 3, 4, 6 or 8. Therefore, there should be at least 24 vegetables in order to arrange them in group of 3, 4, 6 or 8. And this is our solution. Now we have the last part of a chapter. That is a very important fact about HCF and LCM. Product of two numbers gives us LCM into HCF. Okay, if in problem they give you the product of two numbers and give you the HCF and ask you to find LCM, in that case we have to use the formula LCM equals to product of two numbers upon HCF. And if they ask you to find HCF and give you these two things, then that time HCF equals to product of two numbers upon LCM. So let's see one example based on this. Find the HCF of two numbers if their LCM is 90 and their product is 720. So which formula I have to use? Find the HCF means we have to use this formula. So before solving this, let's write the formula, the given things first. Here what is given? LCM. LCM equals to 90 and product of two numbers equals to 720 and HCF equal to question mark. So we have here formula HCF equal to product of two numbers whole divided by LCM. Let's substitute the values. Product is 720. Divide this by 90. Cancel the common zeros. And when we divide 72 by 9, we'll get answer 8. That is HCF equals to 72 upon 9, that equals to 8. Therefore, HCF will be 8. Hope you have understood this. With this, we have finished the chapter as well as the portion of half yearly.